I'd like to welcome everyone to the second in our distinguished lecture series organized by the Center for Digital Agriculture. Matt Hudson and I are the co-directors for the center, and we are starting the series this semester as a way to bring in some of the most distinguished researchers in different aspects of digital agriculture. And we hope that you all will find these speaker events valuable in exposing us to some of the most prominent and distinguished work that's happening. Today's speaker is hosted by Professor Isabella Condotta, who is a assistant professor in the Department of Animal Sciences. Her background is in engineering, and she brings engineering and computing techniques to animal management and precision livestock farming. So let me hand it over to Isabella to introduce our speaker today.
Daniel Berkmans has a master's and a PhD in bioengineering. For 20 years, he headed as full professor the research division M3 Bioris, which stands for Measure, Model, and Manage Bioresponses, at the Department of Biosystems at the Catholic University of Leuven. He is also adjunct distinguished professor at the University of Tennessee. Then is founder, board member, and CTO of BioRix NV, that is focusing on continuous monitoring of human and animal mental and physical health. In education, Dr. Berkmans was teaching 8 different courses at the bachelor's and master's level. His research focused on real-time monitoring of health and well-being of individual humans and animals. He co-authored over 340 peer-reviewed publications, over 450 papers, participated in 64 PhD committees in 9 countries, and promoted over 250 master theses. Since 1982, 19 products for the world market have been co-developed with industrial partners. Dr. Berkmans is the co-inventor of 20 patents and coordinated several European Union projects. Daniel is worldwide considered as the spiritual father of the field of precision livestock farming, which involves the real-time monitoring of animals with technology, such as microphones, cameras, and sensors. He co-started the European Association for Precision Livestock Farming that organizes since 2003 the yearly European Conference for Precision Livestock Farming, or ECPLF. Today, the conference is organized in agreement with the Asian Conference for PLF and the US Conference for PLF. Dr. Berkmans co-initiated the first European Masters in Human Health Engineering at the KU Leuven, which involves the use of technology for monitoring healthy people. Then is co-founder of 3 spin-off companies, BioRix NV in 2006, BioRix INC in San Francisco in 2016, and Sound Talks in 2011. He is a member of the recently started Scientific Council for the World Farmers Organization, which represents 1 billion farmers worldwide. KU Leuven was ranked by Reuters as the 7th most innovative university worldwide in 2020, with 130 spin-off companies so far. And I hand over to Dr. Berkmans to give this talk. We are all excited to have you here. Thank you very much for agreeing.
Many thanks, Isabella. Thanks for the opportunity to speak. As we said, let's give it a try. And let me first say a short overview. So first I will say who we are, what KU Leuven is. Then a small definition, because there is still several different definitions for precision livestock farming. I think it's good that we have a same understanding. And I will try to give 7 reasons, 7 arguments why I think PLF might be a game changer for the worldwide livestock sector. Okay, Catholic University of Leuven is a very old university. It started in 1425 under direct question of the Pope of Rome, because he wanted faculty in theology in the lowlands. Leuven is a very small city. We are about 25 kilometers northeast of Brussels. We have 100,000 people in the city. On top of that, we have over 62,000 students. So it's a real student city. KU Leuven is a very nice university to work because it's a very competitive environment. As a professor, you are paid to teach. If you want to do research, you have to find your money. And that is, I think, why we are struggling or fighting and getting the opportunities and creating it. It's in Europe not that obvious to have this mentality in universities. Leuven, as I said, is very old. Here you see the Department of Architecture. That's in the area, the park where we are. That is one of the student restaurants. This is the city hall. This is the longest bar in Europe because it's only cafes, and very strange. Leuven is the only place in the country where they are not closing during the night because the students don't accept it. This is one of the libraries we have. So fun to work here. Okay, the M3 Virus team, the big secret of what we did was collaborations with others. In Europe, we have research funding like you people have in the United States. And what I can feel that the competition for money is, of course, very high. But don't worry too much about collaboration. That is the way to go. Collaborate as much as you can with other people, because what is important is to make progress. Whether it's you who do it or other doesn't matter, because that, I think, was what we could manage. We had rather big European projects, 5 million, 8 million per project. We pulled in like 20 partners, and that is the key of our success. Now, meanwhile, we try to do the same thing in University of Tennessee. And my advice and my invitation is we will contact many other teams in US to work with us. So also there, we start up several PLF projects, and the strength is to collaborate and go together for the funding. At the same time, Byrix is one of the spin-out companies. That's where I spend most of my time now. And also this company will go in animal monitoring as soon as the sensors are strong and available. Okay, let me give the 7 reasons why I think PLF might have a chance to change the livestock sector. The first thing is the time is ripe for it. Why? Because we are facing huge challenges. And it's when everybody can see we cannot proceed the way we do, then it's the time to bring challenges. Look, my grandfather, he had more children than cows. He had 6 cows and 10 children, and all of them had a first name. And he was more busy with observing his cows than his children, because he had all the time. He could know the character of each individual animal. Today is a totally different situation. Farmers are squeezed to have so many animals to make their living out of producing animal products that it's a totally different picture. I remember the day that my grandfather was buying like a few thousand broilers, and I was 12 years sitting beside him, and he was wondering how, for God's sake, he would know what these animals needed. And that's the sad story in some way of where we are today. So what is the big problem is the farmer has no time for individual animals anymore. So we tried in Europe to do several approaches. It was driven by a lot of money from the European Commission. Already 40 years ago in UK, there was the observation in slaughterhouses to see whether there was a bitten tail, which means in that farm is a problem. Then we had the welfare quality approach that took 25 million euro, where humans are scoring farms, which is nice once a year, but is far away from continuous monitoring. And that is the objective, what we try to do with precision livestock farming. The big challenge is this year, over 70 billion animals will be slaughtered for the demand in animal products. And the expectation is that by 2050, there is a worldwide increase in the demand for animal products because more people can afford to buy animal protein. We don't have to explain in COVID times what the relation is between animal health and human health, because over 70% of the diseases we get, they come from animal. That means that animal welfare, maybe you don't realize it, has a very strong link to human health, because all the food energy which is burned in the lack of animal welfare, that is not available for animal health, is not available for production. So animal welfare is in the center of it. In the same time, if we burn a lot of food energy to not produce an animal product in an efficient way, we produce too much manure, too much emission. We have not a good feed conversion rate or growth rate. Because even today, if we grow animals in the laboratory, it's about 20 to 30% more efficient than what farmers can do. So social importance in Europe, especially in my country, the whole society looks down to the farmer who's working with animals. He is considered like the man who is abusing animals. Most farmers who work with animals, they are far away from that idea. Social importance is like in the BSE crisis in UK, over 40 farmers committed suicide. In 2019, worldwide, over 10,000 farmers committed suicide. And economic importance is not only the export of meat or milk or eggs, it's also exporting technology. And that is what our message and mission is in precision livestock farming. Okay, time for changes is also very nicely illustrated by the 17 Sustainable Development Goals. I for sure don't have to explain this, but if you look closely to them, half of them are strictly correlated to animal production. No poverty. In developing countries, animals are the key for people to survive and have a certain social status. Zero hunger, good health and well-being, clean water, climate, life below water, all strongly correlated to the livestock sector. So reasons to bring change. The definition is, okay, we use technology, we use images, we use cameras, sound, sensors, but what is important to say, it is a tool for management. What do we mean? It will replace nobody. It will not replace a farmer. It will not replace a veterinarian. No, it's a tool that brings objective, continuously measured, automated, real-time monitoring for different aspects in the management of livestock. It's helping farmers, veterinarians, and all the food experts, the infection experts, everybody. It's a tool. It will not change the world. Human will change the world. It's people who will do that, but this is support. Okay, that's important. The second reason is precision livestock farming as a scientific basis. And we started to do this research in 91 because in Leuven you have to come with very innovative research to get funding for your research that you have to catch at the regional, federal, or European level. So you must come and focus your whole team in one thing. And what we discovered in 93 already, that monitoring an animal is totally different from monitoring electromechanical systems. The first step is what your field is much more complex than electromechanical systems, because this is what happens in one cell. It's not the objective that you can understand it, but somewhere in there is the Krebs cyclist, who is the key of everything, because that is where metabolic energy is generated. So that's a crucial thing for all living organisms on Earth. This is much more complex than what we can imagine or what we have produced so far. So don't try to do this with descriptive models. It will never work. A second thing is, we look to animals in this way. They all look the same to us. And I think they look to us in that way, in the same way. But in reality, they are individually different. And even top journals like Science on Nature or the Lancet, they always come with population statistics. So we still need to prove something on a few thousand people. It doesn't make sense. Statistics with averages and standard deviation is nice to compare groups, but not to work on individuals. So they are individually different. Here you see a test. This is the time. In the x-axis of all my graphs is always time, because it's all about dynamics in time. And here you see 5 students who go to an exact identical exercise on a bike in the laboratory, and you see they have individually different heartbeats, which is absolutely normal, living organisms. Look, if we have a population, that's the one graph where here is no time. This is the average of a population and the standard deviation. But somewhere in that population is an individual that has, for whatever variable, a very small standard deviation compared to the standard deviation of the population. For example, the standard deviation of the heart rate of all US people is much bigger than of one of yours. So, and important, has variations in time. Statistics using the average and the standard deviation is to compare groups. That's fantastic. To compare a treated group versus a control group. It is not the way to go to study individuals. Another important thing, electromechanical things, we can produce them completely identical. It doesn't matter how complex they are. If you take 2 animals, even if it's 2 clones, and you do something to them, they will respond in an individually different way. There is not so many systems who are so individual as the immune system of a living organism, because each living organism has a different history in what he or she went through in life regarding immune and infections. Another interesting thing, living organisms are time varying. And what that means is not that they are dynamic. Of course they are dynamic, but they are time varying means you do something to them, like here, for example, here is the time. We put a chicken 5 days old, a broiler, in a respiration chamber. We suddenly decrease the environmental temperature. The animal is worried about keeping body temperature constant, so is increasing the individual heat production. The same individual 25 days later does it in a totally different way. Here is still a waste of energy. It's a second order system. Here is a first order system. No waste of energy, or much less waste of energy. So every time the animal is responding to something, it can be in a different way. Another example, your friend or my wife is asking me something on a Saturday evening, 10 times the same questions, let's say 10 weeks on a row. And then in week 11, she's asking the same question on a Monday. And I've answered it very nicely 10 times, but the 11th time I'm under time pressure, I give a totally different answer. Time varying. So we are time varying systems. That's why we call, since 2003, we published this, living organisms are complex, individually different, time varying, and dynamic, C.I.T.D systems. That has huge consequences on what technology we can use to monitor them. So what we could see, we have to measure, we model the individual living organism, and then we can manage it. It all has to go in real time. It has also serious consequences on the type of models you can use to monitor living organisms. We can discuss this more when we talk about artificial intelligence. Okay, as I said, the team, the secret, I've already told that. Look, we started in 91 on insects, on tubifex, which is used to, that's a larvae, which is a bait for fishing. Water fleas, where we tried to predict where they would swim in the next few seconds by camera. In 93, we did a project on pigs. The first project on 3D image analysis on pigs, 93. Then mussels, larvae. Then we did the whole livestock species. And in 2001, we launched that word, precision livestock farming. And in 2002, we started to work on humans. And after that, half of the team is working on humans, half of the team is working on animals. And in 2014, we started human health engineering. In my country, I'm not happy to say it, we have every year, beside the 25 to 30 PhD students continuously in the research team, we have every year 25 master students. Only 3 of them work on animal. All the rest is on human. And when they discover after some time it's the same, that to monitor and model them, then they make a PhD on animals. But the US is totally different, fortunately. Okay, the third reason is a C.I.T.D system, as we have explained, needs continuous automated monitoring. So humans, which is worldwide a technique to observe animals, that's subjective, that's the first thing. It is momentaneous, like the welfare quality once a year. It's not automated, humans make more errors, so there is huge differences. Let's look to some examples. Early warning of lameness in cow, that is real-time image analysis. So the experimental facility, yeah, as I said, we have never done a project on our own, not a single. In the 30 years that I was heading the team, not a single. We always needed to work with partners. Here it was a group from another group of Belgium, Israel, Estonia, and Finland. This was the test facility. So we always pushed the gold standard to another team, the experiments, the labeling. We only do the algorithms and we share all the results. That means publications, patents, even shares in spin-offs in equal parts. That's how we could create good results. Gold standard in this case was a single expert in Finland. Amazing, because we took 3,000 videos of cows. One and the same expert, a veterinarian, every week was scoring the animals for lameness. In Israel, there was a few experts. In Belgium, also one. The big challenge is to find the feature variable. What is the feature variable? Yeah, maybe first to say the gold standard is the scientifically robust way that is available to score the effect. Can we see when a cow is lame, yes or no, and in what level? If there is no gold standard, don't go into that project. We refuse 70% of all projects because there was no robust, reliable gold standard. The feature variable is a totally different thing. That's a very simple to measure, cheap to measure, accurate to measure, simple variable that contains the information we are looking for. In this case, for example, step overlap, easy to get from image. The step overlap is whether the position of the hind leg comes further than the position of the front leg, positive or negative. That is one. Another one, the step time. That is the duration that the leg has no ground contact, or very simple to get from image analysis. I can show them all, but we don't have time for that. In total, from image, we got 13 potential feature variables. There was the stance time, the stride time, the step length, the back arch. That was farmers, a few farmers who suggested that. The touch angle, that is how the hoof is touching the ground. The release angle, how the hoof is releasing. A complete dynamic model of the gait analysis. Then asymmetry in step overlap. The ratio between swing time and stance time. Asymmetry in step lengths between front or back or left and right. And then the range of motion. The most complex model was this. We were believing this is it, this will do it. Every time a cow is walking away from the milking robot, we take a complete gait analysis and we can calculate many of the dynamic variables. Now, what came out when we started to test in different farms, that what the farmers suggested was the good one. That was the back arch. So that is when a cow has a problem in one of the legs, at some point, she will try to take away the weight of that leg, and therefore she needs the back muscles. And so you get a different arch in the back of that cow. And if we monitor that one, that could explain over 80% of the lame cows. In Belgium, we are small in everything, except in one thing where we are much bigger than everybody in the world, that is in paying taxes, but that will not interest you. In Israel, we had a very nice facility with 250 cows, really good, great facility to work and nice to work with them. In Estonia, we had a farm with 5,000 cows, and we took over 3,000 videos with gold standard every week. And here you see in time how the algorithm that adapts to each individual, you have understood that, how it shows in time, like the yellow one, okay, the treatment seems to work. For the red one or the indigo one also, the treatment works. The blue one is lost. You have 5 levels of gauge score. When the challenge for us was to detect from healthy to the first sign of upcoming problem in lameness. And that was where we were working for in the algorithm. Here you see what the gold standard says. There is again time. The veterinarian could say this cow gets this score, and here you see how the algorithm detects the same thing. The commercial prototype was a top view system, very simple. We used the Microsoft Connect. You get it almost for free, this arch of the back arch. And a top view, because then the background is stable, which you don't have with side view. Another example, infection monitoring by sound analysis. That was in collaboration with University of Milan, and the spin-off we started SoundTalks. What is strange is that you see in 1999 we did the research project, and we started SoundTalks in 2011. So that is what you people have to understand. The research is so far ahead, and we need people like you to push research, to bring it faster to the field, because that's the big gap for precision livestock farming. We need much more implementation. So the idea was, if an animal gets infected, and for pigs, often it is respiratory diseases, then it is the air pipe which is infected, or the lung. In cattle, it's most of the time the lung. But like for humans, if you had a respiratory infection, you hear it like now in my voice. I was sick. You can hear it in the voice. So the idea was, why don't we use sound analysis so that we can send a signal to the farmer if there is a detection of a sick animal. What happens when there is an infection? The cells of the air pipe will respond to it. And so physically, if the cell wall has different characteristics, we expect a difference in sound, like we do when we cough, when we are sick. And that was the idea. And here you see how the algorithm can detect between sick coughs and a healthy cough, if that exists, because in the environment with dust and gas concentrations, there is always coughs. And there is also other signs, which is a serious challenge in sound analysis. This is a result of a European project where we applied PLF technology with camera, sound, and sensors in 20 farms all over Europe during 4 years. This was a blind test. Here the animals came in. This is the whole fattening period. Animals came in. The farmer only detected here, blind test for him. We wanted to see when he would treat the animals. Animals were sick a second time. There the farmer treated, and the third time the farmer didn't realize it. So he didn't make any money on those pigs. Because you see, every time the system detected an infection, the feeder system could not fill the troughs because the animals were not eating, loss of production. So the system was working quite well. There were several teams in UK who evaluated the system in a neutral way, away from SoundTalks. And it's a pity to say, today SoundTalks has over 27,000 orders, and they cannot deliver because in their system, in the motherboard, there is 300 components and there is one microchip they can't get. So it's not only the car industry that is suffering. They paid more than €1 million to get the chip with the promise it would come in the next 3 months. And after that, 6 months later, they got the message it will only come in 2023. So that's where they are. Okay, they can also localize not only in which compartment, but also in which pen there is a sick animal. And the idea is that the farmer or the vet can immediately treat the animals that are in contact before there is a spread out throughout the compartment. Also, the sound monitoring app will show which farm has infection. So for the veterinarian, it's interesting to follow which customers he has to visit. Another technique is real-time monitoring of feed intake. That is a challenge. We were struggling and standing and falling for 3 years with sensors on the animal until we got the idea to put a microphone in the feeder pen. And what you can see here is that the gold standard, there is two things. The gold standard is a very accurate weighing scale under the feeder pen, where the labeling is done by this video. The video, that means we have 25 images per second, and we check whether the animal is really eating or is playing, because now it's hungry, that goes quite well. But when it has fulfilled the first package, that will also start to play. And we also collected every particle that was lost. They lose less than 1%. And then the algorithm is selecting the sound packings where the animal is really eating. So that is what we do from sound analysis. Here you see the number of packings in the blue line, and the green one is the feed intake per minute measured by the weighing scale. And you can see this is grams. You can see how accurate the technology is. Strangely enough, so far, we could not convince a producer of feeder pens to implement this technology, but that will come. That's one of the projects we start in Tennessee now. Another one, real-time weight estimation. The idea is not from us, that is from Paddy Schofield in the 90s, where he got the idea to take pictures and to correlate the image of the pig to the weight. Paddy did that when they were eating in a standard position. What we did is we do it from video images. So you see, these are not in standard position to correlate this surface to the weight. But as soon as a pig is in standard position, we calculate the correlation. In a normal pen of 10 to 15 pigs, like mostly used in Europe, we have about 4,000 hits a day. And that goes to the farmer, this information. It is yet not accurate enough. If you combine it with the identification of the pig, you can see it's very accurate. But if you don't have that combination, it's still 0.8 kilogram. What is that? That is 1.6 pound. That is just too much to use it on piglets. You can only use it like in Italy for the Parma ham. They grow fattening pigs to 120 kilograms. So we have to do a better job. Another fascinating one and very interesting, and that was in the European project, that is a aggression monitor that we did together with University of Milano, because this team always did labeling for us. In 2000, I could convince them to focus on labeling. It's in the veterinary science, faculty science of Milano, and they do all the labeling in all our projects. We make sure they have budget. There is the Tierhochschule, that is the veterinary faculty in Germany, North Germany, and a company, Fancom. Aggression is normal. When you make a new group of pigs, you get aggression for ranking. That's no problem. But we don't want this level of aggression that you see on the top left here, where they scratch each other, they hurt each other, and that will give lower value in the slaughterhouse. We have tested in a PhD several algorithms. The first one was a very complex one. We looked to the movement of every individual pig. It was too expensive in calculation time to bring it in a low-cost camera, so we forgot about that. Then we looked to the shadow of movement. That didn't need so much calculation time. So that was fine, that worked, but still too complex. It took us 2 years with a lot of observations, that is labeling. And here you see the feature variable. That is simple, the distance between the back of the fighting pigs and the camera lens. Yeah, you get that for free. You get in a camera which measures 3D distances. After that one, we made even a much more elegant algorithm, and that is for those who are with me on the mathematics. We take the pigs all as vectors, two-dimensional vectors, and we just calculate, we put them in a matrix as a function of time. We have 25 values per second, and we calculate the rank of the matrix. When there is fighting, there is more order, so the rank is lower. Very simple, very elegant. Sorry. You see that the algorithm was not so bad. We had sensitivity, specificity, accuracy, not bad at all. But so far also that was not integrated in a product because the companies were less interested in taking the moment of aggression, although it's very important. This is the way to go. And this is the type of algorithms that Byrix is doing. So what you see here, the horse is wearing a heart rate sensor and a movement sensor. This is the amount of and metabolic energy used to move this, 500 to 600 kilogram horse. We calculate that from movement and from heart rate. I can explain that. It's all also published, but we can explain that later. What you see here is the mental component. This is the amount of energy used by the brain. That is the animal welfare. Now, what is the exercise? The horse is trained to run one circle, and it knows we will show feet. So the student, the master student, is showing feet to our horse. You see, animal is interested, but it also knows it doesn't get the feet. Less movement, less metabolic energy for movement, still relaxed. But when the horse is used to this, we don't give the feed. We want to frustrate the horse and then to see, can we monitor that frustration in real time? And here you see the animal goes in frustration, and there is the amount of energy used by the brain. That is the frustration. It takes time to calm it down by the voice. And we've done several tests with the police in Brussels who have 250 horses. And it always works. It's all individualized real-time modeling. Okay, so the scientific background and the examples must convince you that the technology is very powerful. But another very important reason, what we have seen in European projects where we had farmers from different countries, like 12 different countries, we had pig farms, broiler farms, and dairy farms. In 12 different countries, that means 12 different languages. We did several workshops with them, and we could see that what they need is a new industry, and that will go for the whole ag sector. So it will not be the computer shop in the village or next village that will do the installation, the sales, and the maintenance of all this technology. So it will create a complete new industry. We need that. If you have time, go to the internet and look for the Atlas project, European project, 60 million euro, to make a portal where whatever farm can be connected to whatever company to exchange data. So it's not to store them in a central way, no, to make that companies can bring their PLF products to farms and to exchange data. You will see that the project is now mainly focused on crop, but it will also come to animal. Another very important reason is that consumers absolutely in Europe are getting very strict on information about what happened to the animal, how often was he sick, what about the animal welfare. So our technology that we will develop all together can give a lot of information. Now, it's not about the data. I can talk a few hours about artificial intelligence, big data, Internet of Things. I think that most people are not on the right track to apply it to living organisms. So technology is a tool that will be made. We don't know anything about hardware. We only do algorithms. It all starts from the living organism. The farmer gets information. The expert, like the veterinarian, like we said, is in a key position. We bring more objective information to the expert, and then companies can bring it to the consumer. So that is the trick. But the expert, the veterinarian, the immunologist, the feed expert, that is key people to interpret the data, and that will bring knowledge. Finally, another reason, that is smart data versus big data. Pushing all the data higher up that you monitor on living organisms takes more energy than what your animal will eat. It doesn't make sense, it's too expensive. So you have to calculate at sensor level, camera, microphone, sensor on the animal, in the animal, around the animal. Don't push all the raw data up. You will never use all the data. We monitored 5,000 cows. We had 3,000 videos. Only 1/3 of it, we had the manpower to analyze them. Because labeling 24 hours of video is a man-month work. Then you have 7 activities when it starts. When does the cough start and stop? Cough takes 1.2 seconds. So it takes a lot of labor to do that. Why would you mix inaccurate data with accurate data? You get nothing. Why would you spend all the labor? Because I've asked in several PhDs, people who work with the neural networks and the AI technology, we also use that, but in a specific way. How much of your labor do you need to distract now the relevant, accurate data from your big pile of data? Well, they say 60 to 70%. Why, for God's sake, do you then push the big pile together? Don't do it. Yeah, take a few measurements that are very accurate on a few variables, because the living organism shows in many ways how the state is. The way you walk, the way you talk, the way you look, your facial expression, your voice, everything shows it. Don't measure all those things. Measure one continuously, accurately, and learn to interpret. They really think, the majority of the people today, that the quantity of data will compensate the lack of quality. That's not happening. Yeah. And C.I.T.D systems, since they are time varying, they need real-time information. That's impossible with a multi-layered dynamic neural network with 200,000 parameters, if they know how many parameters are in the model. So what you do is, for example, one image, 25 images per second, gives you over 50 million numbers per second. Every 20 seconds, that's a billion numbers. Don't use that. Don't push it up. Calculate something in the camera and you send 3 numbers. That is, for instance, the distribution, the activity, the time. That's all you need to get meaningful information. Same with sound, 20,000 samples per second. So be smart in using data. And don't use the big data like everybody is claiming now. Never do what everybody is doing. Do what you think you should do. Go against the flow. Then you do something unique, and then you might do something really interesting. The last reason is it will also create totally new business models. Of course, the consumer will always pay at the end. A technology provider like SoundTalks, they might give technology for free to the farmer. Why? Because the retailer who wants information from it, he might pay for the technology, or for the whole system, he has to contribute. The same with the breeding company who wants to test out a specific genetic line, or the veterinarian who wants automated reports, or the feed company, or other companies, or the slaughterhouse. So everybody has to contribute if they want to use the PLF technology. So the good message to farmers is, you make sure you are in big groups, farmers associations, and negotiate contracts. Otherwise, don't give your data, because they create value. You need part of that value. To give some time for questions, the conclusion is, at least from my viewpoint, the fully automated continuous real-time monitoring, and they all matter for C.I.T.D systems, is coming. Nobody will stop it. If we don't do it, others will do it, but it will happen. Why? Because it will contribute to getting a different livestock sector. Today, it can already bring a farmer more close to the individual animal that needs attention. That's why we call it active management tool. The farmer can immediately take action. We did hear that in the workshops from all the farmers in Europe. In the beginning, they didn't understand. Then we give them a 3 days training. After 6 months, they were like fantastic technology. And again, 4 months later, they said, oh, nice. It tells me there is a problem. What I have to do, help me, tell me what I need to do now. So active management tool. That is why it keeps a tool. I don't think it will ever replace a farmer, an expert, or a stakeholder. The real expert on the whole process is the farmer. Don't look down to people who have no diploma, who often are there, although in Europe not so many farmers are today highly educated. But I've seen a lot of people without any diploma. I've seen it when we started Byrix and the project in AC Milan, the soccer team, but they know the process. It's all about process knowledge. And that's another thing AI data crunchers forget. They look to numbers. They even do mathematical functions on a number without knowing what they do. At the end of the day, they add energy with mass and all these crazy things because they don't know what is behind the number. I don't believe in it. The big issue and the big challenge for you and the big message to each of you, what we need now is implementation of PLF technology that asks for collaboration between industry, researchers, farmers, and stakeholders. Researchers are very frustrated about the lack of collaboration between researchers, because I have experienced myself that I had an 8 million euro project and the researchers in the project, they refused to really collaborate. That's too bad. If you want progress, collaborate with whoever you can collaborate in an efficient way. I think this is what we need to get a more efficient process control in the times of climate change and the time where the whole sector needs to change. So I'm open to questions.
What parallels do you see between, I won't call it human farming, but human activity or human understanding and animal understanding?
I would be very blunt and say none.
None?
None. Humans and animals, look, it's all about metabolic energy production in a system, and that is identical in animals and humans. Yeah. In the next 10 years, you will see how intelligent animals are because we start to understand more. Of course, we are more intelligent than animals, but I can show you amazing videos of how animals are and intelligent they are. The problem is that, you know, the problem is that the medical expert doctor looks down to the general practitioner because, no, he doesn't know that much. The general practitioner looks down to the veterinarian because he doesn't know it. The veterinarian looks down to the engineer. The engineer looks down to the technician, and the technician looks down to the farmer, and the farmer looks down not to the animal because he understands animals. Good farmers understand animals. We have done a research in 100 pig farms over 10 years. We followed them with all the data to see what is the best system to grow pigs. Is it mechanical or naturally ventilated, artificial heating or no heating? At the end, whatever system you have, what comes out, it's the farmer that does it all. So I think, don't think there's too many big differences. I don't think so.
And how is time varying different from dynamic? Is it matter of time scale, or is it something fundamentally different?
No, I think that time, look, every process in the body has a different dynamics. Like your immune system has a totally different dynamics than your metabolic energy production. We have developed an algorithm for infection detection. We need at least 25 days of data to run it. Where to predict your weight, we have enough with the 3 past days, and we can predict your weight for the next day. It's all in the dynamics. And like in the first project we did in human was in the intensive care unit. After 6 months, we could say with 92% accuracy, this person will unfortunately die in the intensive care unit, and this person will go alive. Yeah. Why? It was all in the dynamics. If you have an agile system, you have a strong dynamics, but the different components, the physical component, the mental, or the basal or the immune or the thermal, they all have different dynamics. It's all about dynamics data. Biological people, they always claim, let's do the steady state. That is difficult enough, complex enough. I agree. But when it's so complex, you better start doing it in that complexity. That's what I think.
Thanks.
I have a question, and I enjoyed the talk very much. I think that you made a really strong case for PLF. My question to you is about what you said about having a gold standard and only working on problems where that exists. I believe, if I understood you right, what you're saying is you're talking about using computer vision or other machine learning or other techniques and applying them only in problems where there are labeled data, and so you can train a successful model and use that model in practice. And I think that's what you meant by having a gold standard. I think that is true for the current state of the art. One of the things that I believe is going to happen in the future. So I think there are a lot of domains, a lot of problem areas where the volume of data is just far too large to label. And it's also the expense and cost and the human effort required for labeling can be very high. And so what I'm wondering is whether you have tried any techniques like semi-supervised learning or other techniques that try to address lack of labeled data and develop machine learning models, which may not be quite as accurate as fully supervised models, but they may still be useful in practice.
Look, what I have experienced, we developed a number of products, and in the university it's considered that we are a very productive group. I think we are a very poor group. If I see that we needed every year 4 million euro and the low number of things we did. And why is that? Because we lost a huge amount of time with working on a process where we had no reliable scientific gold standard. If you want to look, Mark Schneider from Stanford, he published last year an algorithm to detect infection using wearables. He started from over 20,000 people, but at the end, he only had 120 where he knew exactly when they were infected and that they were really infected by COVID. Yeah, we did the same. We have 185 people now, 1 year later, from which 120 are the Mark Schneider data. Yeah, so but our algorithm is strong. But if you don't know whether the person is infected, yeah, what are you busy with? And you waste your time. You're fooling yourself, because a gold standard is different from labeling. Labeling is, why is my signal changing? Is understanding the process. Where the gold standard is, now I have the information exactly on what I'm looking for. And yes, we've seen. What was astonishing for me in the Auburn conference on artificial intelligence is that people said, okay, now we have 3 models, which is the best? Oh, we can do this, we can do that. But why don't you use a gold standard to know which is the best model? Because look to the amount of money you burn in using your brain working on data without having the real answer. And I will not do that anymore. And I had to disappoint many colleagues because I said, no, with this inaccurate gold standard, we don't go for it. But who am I? I'm just somebody, yeah?
Yeah, okay, I completely agree with that. I think what you're saying is it's not about the labeling of the data to train a model. It's about, do you have a correct answer against which you can compare the outcomes? If you don't have that, then it's difficult. But so we are facing that challenge in the livestock work. For example, we have seen for the pig videos, the team here has been labeling pig videos with behavior labels, and even expert PhD students or graduate students in animal sciences or who are livestock experts sometimes disagree on what the behavior might be in the video. And that's one of those cases where it's not clear what is the right thing to do. But you're right. In those cases, there is no exact answer.
No, but when the experts who try to go in the process disagree, that is the opportunity to gain insight.
Yes.
Yeah. It's always the surprise that it doesn't work, which helped us. It is like people, you grow when you suffer.
It's a research opportunity, I agree.
Yeah, you know that what Einstein said, a good scientist is not depending on his intelligence, but on his character.
I had not
You
heard
have
that
to be
quote before, but that
persistent.
is a very good
We
quote.
have to be persistent. Yeah.
Thank you.
Thank you for the questions.
Daniel, I had a question about technology acceptance. So I work in the beef cattle realm, and so we have a lot of small producers and a not very integrated industry compared to the broiler, in poultry and even the dairy industry. And so what's been your perception on technology adoption by smaller producers compared with the more integrated and corporate level kind of farms?
That's a very good question, because you know why it's so important, your question, Joshua, because in many countries, the majority of the farmers who have to produce the food are very small farmers. In Turkey, over 90% of the farmers who produce milk, they don't have 15 cows. So very good point. So the challenge is that we make the technology so cheap that also they can use it, that they can afford it. That's number one. Yeah. But that means we have to produce many high numbers of that technology, because the cost of technology is just depending on the numbers produced. And if you look now to, for instance, a phone, you can get very cheap phones these days. There is about a small 8 billion people. Not all of them have a phone, but still that makes phones quite cheap. But if you think about the livestock sector, 8 billion is nothing in the livestock sector. As we have seen in the beginning, every year we slaughter now over 70 billion animals every year again. So the numbers are there, but we need the technology. Like the SoundTalks product still is quite expensive, I think, for small farmers, but that is because it is produced in so limited ranges yet. If they take the basic material for 50,000 units, then maybe they need 2 years to get them sold. But once they can buy the particles for 1 million, then it becomes a totally different story. But the farmer will accept it at one condition. Farmers are very smart if it gives them money. And it's us who have to prove that. It's the researchers who have to prove that this technology gives money to them. And if it does, and I would produce that technology, I would say, farmer, you get it for free, but I want this part of your profit. If we are convinced, yeah.
Thanks. Yeah, I definitely agree on the scalability of the technology is really important. And I've kind of also, put focus on there and kind of like against wearable technologies that just aren't going to scale at a economic kind of reasonability. So
we will see. We will see. The wearables, I think, so we have always worked with images and sound because we didn't want to touch the animal. We were afraid that we influenced the animal. But I must say, the last 7 years, if I see the results we got on humans with wearables, I'm absolutely convinced it will come, that we have an ear tag. We are not so far away. That doesn't need any recharging, that measures heart rate and activity. And then we measure infection in animals. Like SoundTalks is doing it for pigs, but then we can go to dairy, to goat, to camel. In developing countries, poor people are in the front line of getting infections. That's my big dream. A very cheap technology for people, not all this fancy stuff. They only need heart rate and movement, and we monitor infection in the animals and in the people. It looks very cold where you are.
Well, it's going to be, but we're praying for spring to show up soon in Illinois. So
okay.
Do you have any models that could serve as a kind of an intermediate stage where you have, lots of the small scale poor farmers who could go to the nearest entrepreneur? He would buy the technology from you, but then he would recover the cost from letting it be used by a whole group of them. So he's kind of the middleman.
Yes, but that's a very interesting thing also. If we want to help small farmers wherever they are, we need the whole structure, and EU is now paying some technology to go in that direction. But I think that's one of the in Tennessee now, I try, as I said, we will also pull in other teams. We try to start PLF projects now. There is only one that I will coordinate myself. For the rest, the colleagues will do, and I will help them. But that is one that I would like to do. How do we bring the technology now to very small farmers? Yeah, because the majority of the farmers worldwide are small farmers. Now you can say, but 90% of the animal products are produced by 3% of the farms in the world. All fine. But if all these farmers lose their income, that's a disaster, especially in developing countries. That's a disaster. So we need to set up a structure. We need to pull in, we have written a project of $30 million with FAO and the World Bank to go to small farmers. And it is not financed yet, but that is where I really like to spend my time, because this is the key. The technology is just a tool. It's just a part of the whole thing. We need much more needs to be solved before we can help most farmers in the world. You have a very important point there. The One Health technology, that's what we have to bring, because the user, the consumer is in Europe is losing trust. And another thing is this artificial meat. It's welcome, because we will not only do it with animal product. We need it all. We need vegetables. We need artificial meat. We need it all. If the worldwide demand is increasing with 70%, we have a big problem. So, but that type of structure that you talk about, we still have to set it up, I'm afraid. It will only happen when a worldwide player, a company, is supporting the idea. And I think that will come, because young people, they see that we cannot proceed the way we do it. We need to produce on this limited earth in a different way. And if a big company will go, and that is my challenge, in September, I'll be back in Tennessee. The project concept note is written, but then we approach very big companies to support us in that idea. Yeah. Thanks for the question.
Thank you. I kind of missed out on your comment about when two experts disagree on the ground truth, then how can technology help? I think you answered that question, but I didn't get it.
Look, the experts now get more information. They get more objective, accurate information from a sensor or sound or image, much more than they ever could have. Yeah. So I think that if they disagree, they will discuss that is science. You need disagreements to make progress. You need disappointment to get progress. And that is our challenge. We need to, a serious expert will always go into that. But I think that the PLF technology can help them to gain more insight. It is the experts, the process expert, who will explain to the technicians, to the engineers like me, this is what you have to make. Because the progress in the hardware and the software was so fast that the experts couldn't follow. And what is wrong is that a lot of technical people, they claim to the medical people, but this will solve it all. Now we do it with AI and technology. Forget it. We have to enforce the experts, and people have to help people. That is what I think we have to do.
Thank you.
Well, now we passed our time already, so I'll just thank you, Dr. Berkmans, again one more time. And thank you for who is here still participating, and we'll see you guys on the next talk.
Thank you, Isabella. Thank you, and bye-bye.